So good morning friends, this is Dr. P. Munaswamy, Professor, Department of ECE. So today you can see the problems, how we are going to solve the problems and the modulation techniques. Especially we are going to take the amplitude modulation techniques, how we are going to design the sum of the frequency parameters, modulation index, all the things we'll take in this class. So here you can take the beginning, you can brief that what are the different types of the modulations. That is, before going to the actual problem solving, you can see so what are the different types of modulations, including the digital. Here you can see the complete types of the modulators or modulations. So overall, you can take so this is broadly you can classify the two types of the modulation techniques. So one is the continuous wave modulation, another one is the pulse modulation. So in case of the continuous wave modulation, you can see that so the modulation can be taken continuously. So that indicates the carrier signal used in case of the continuous wave modulation is continuous. Especially for this case, we are going to take the sinusoidal wave, which is a continuous, can be act as a carrier signal for this continuous wave modulation. Whereas coming to the pulse modulation, which is the second type, so here instead of taking the continuous wave, that is sinusoidal wave, here we are taking a train of pulses, a group of pulses can be act as a carrier signal for this pulse modulation techniques. So that is the difference between the continuous wave modulation and the pulse modulation. So in case of the continuous wave modulation, you can take the sinusoidal signal, which is the continuous, as a carrier signal, whereas in case of the pulse modulation, a group of pulses or train of pulses can be act as a carrier signal. So then coming to the further classification. So under the continuous wave modulation, we are going to have the broadly under the continuous wave. So there are two types are there. One is the amplitude modulation, another is the angle modulation. So amplitude modulation, you can define that the amplitude of the carrier signal is varying according to the instantaneous value of the modulating signal. So that means the basic parameter variation here in case of amplitude modulation is amplitude. So the amplitude of the carrier signal is varying according to the strength of the or instantaneous value of the modulating signal. Then coming to second one, angle modulation. Again, this angle modulation is classified into two categories. One is the frequency modulation, another one is known as the phase modulation. So under the frequency modulation, the frequency of the carrier signal is varying according to the strength of the modulating signal or instantaneous value of the modulating signal. For any case, any modulation, the strength of the modulating signal or instantaneous value of the modulating signal will be same. Based on this value of this modulating signal, the property of the carrier signal, it may be amplitude or it may be frequency or it may be phase. So based on the variation of the parameter or feature of the carrier signal, we can say that the concerned modulation. If the amplitude of the carrier signal varying according to the strength of the modulating signal, we can say that it is amplitude modulation. The variation in frequency, that is the frequency of the carrier signal, is varying according to the strength of the modulating signal, you can say that it is a frequency modulation. Now take the phase modulation. Phase of the carrier signal varies according to the instantaneous value of the modulating signal. That is phase modulation. So that is we are going to consider three parameters: amplitude, frequency, and phase. Then coming to the under the pulse modulation, again we are going to have the two classifications. One is the digital modulation, another one is the analog modulation. Under digital modulation, completely we are going to perform the modulation in terms of the codes, pulse codes. So that is the example for the digital modulation. So that is the complete modulation will be taken in terms of the binary codes, that is zeros and ones only. Best example for this digital modulation is pulse code modulation, PCM, or the advanced sum of the drawbacks available in this PCM code, pulse code modulation. It can be overcome by the modulation known as a delta modulation. So under the delta modulation, again advanced with the adaptive delta modulation. You can see the later. So these all the modulation techniques will comes under the digital communication system, whereas AM, FM, PM will become under the continuous or analog communication system. So analog modulation, again we are going to have the three types. One is the PAM, PWM or PPM. So here the continuous, instead of taking the carrier signal as the continuous, we are taking a group of pulses, a train of pulses, that is rectangular pulses can be act as a carrier signal for all the modulations of these three under the analog modulation: PAM, PWM and PPM. PAM stands for pulse amplitude modulation. PWM stands for pulse width modulation. PPM stands for, it is a pulse position modulation. So pulse width modulation is also known as a PDM, pulse duration modulation. Pulse duration modulation. So that is the another name for the PWM, pulse width modulation, pulse duration modulation. It is also known as a pulse time modulation. Then coming to the PPM, pulse position modulation. So here also we are going to take the three parameters of the carrier signal of the pulse. One is the amplitude, another one is the width, and third one is the position of the leading edge or trailing edge. So the amplitude of the carrier pulse can be varying according to the instantaneous value of the modulating signal. Then it is a pulse amplitude modulation. Whereas coming to the pulse width modulation or pulse duration or pulse time modulation. So here the width of the pulse can be varied according to the instantaneous value of the modulating signal or strength of the modulating signal. Then it is known as a pulse width modulation. The same can be known as a pulse duration or pulse time modulation. Then pulse position modulation. Here we are going to take the one pulse. This is one pulse of the rectangular. So this is known as a leading edge. So that is a varying from 0 level to some high level. Downing from the high level to 0, it is called as a trailing edge. This is trailing edge, this is the leading edge. So that means, so the position of the leading edge or trailing edge. This is the leading edge, this is the trailing edge, downing from the high value to lower value. So we can change any one of the position. So that is the position of the pulse. It may be leading edge position or it may be trailing edge position. So based on that, we are going to have the pulse position modulation. The position either of the leading edge position or trailing edge position can be changed according to the instantaneous or strength of the modulating signal. Then it is known as a pulse position modulation. So these are the briefing of the different types of modulation. For this case, we are going to take the problem solving. We are taking the amplitude modulation here. So these are the different types of the analog modulation: PM, PWM, PPM, what we discussed in the previous slide also. So digital modulation we have taken, PCM, pulse code modulation, delta modulation. So what are the drawbacks available in PCM can be overcome by the delta modulation. Again, we are going to take the what are the drawbacks available in case of the delta modulation is overcome by the new one. It is known as a adapted delta modulation. So these are some of the examples for the digital modulation techniques. Now we can take the example of the amplitude modulation of the pulse. So whatever it may be, the difference between the continuous wave modulation and pulse modulation, the carrier signal in case of the continuous is sinusoidal, which is a continuous variation. Whereas in case of the pulse modulation, a train of pulses can be act as a rectangular pulses can be act as a carrier signal. So here this is our original modulating signal. First one, you know that. Then coming to this is the sample signal. So this is the carrier signal, sampling signal, nothing but. So these are the rectangular pulses which can be act as a carrier for this pulse modulation technique. So here we are going to consider the pulse amplitude modulation or amplitude modulation. So the amplitude of the carrier signal will be varying according to the instantaneous value of the modulating signal. So this is the initial value of the modulation 0. It will be going on, it is increasing towards the high value. So that you take the carrier signal, train of pulses, which is originally having the uniform amplitude. So all the pulses having the uniform amplitude. After operation, that is after completion of the modulation, the name itself indicates the amplitude of the carrier signal will be varying according to the instantaneous value of the modulating signal. So that is the, here you can take this is the highest value of the modulating signal. The corresponding, the variation of the carrier signal amplitude is increased to high value. So that means the proportional variation. So according to the proportional variation of the modulating signal strength, the amplitude of the carrier signal will be varies. So by joining all the peaks or tops of this modulating carrier after modulation, it represents the or reconstruct or realize the our carrier modulating signal. So that means the name itself indicates the amplitude of the carrier signal will be varying according to the strength of the modulating signal. The variation of this uniformly arranged or generated carrier signal amplitude is varying like this. So this is our amplitude modulated signal. So after modulation operation, we are taking this one. So this is about the how modulation will take in case of the amplitude modulation. Now you can see the problem solving. One of the problem we are taking. So how we are going to take the calculation of the carrier frequency, frequency deviation, and modulation index, and bandwidth requirement for this AAM. So you can see the problem. A sinusoidal modulating waveform of the amplitude 5 volts and a frequency of the 2 kilohertz is applied to a FM generator which has the frequency sensitivity of 40 hertz per volt. So always frequency deviation or frequency sensitivity is measured in terms of the hertz per volt. So here for this case we are taking the frequency sensitivity is 40 hertz per volt and calculating the frequency deviation, modulation index, and bandwidth requirement for this modulation. So that means from this given problem, you have to take the first what are the data given requirements. So first one is the amplitude of the modulating signal, the sinusoidal modulating wave, which is having the voltage of 5 volts. So that means amplitude of the modulating signal voltage is indicated by AM, which is equal to 5 volts. So according to the problem given here. Then coming to the next one is there is a frequency of the 2 kilohertz applied to the FM generator. So that means the frequency of the modulating signal, that is FM. The symbol used for this modulating signal frequency is given by the FM. It will be equal to 2 kilohertz. So that means from this given problem, given statement, we have to take what are the minimum data given by the statement or problem. First one is the amplitude of the modulating signal, that is indicated by AM, that is 5 volts. Similarly, what is the frequency of the modulating signal? Corresponding amplitude is 5 volts and the corresponding frequency for the modulating signal is FM is equal to 2 kHz. And same time another parameter is given is frequency sensitivity. So that is a symbol used for this frequency sensitivity is KF. So KF equal to 40 hertz per volts. So these are the known data given by the statement or problem. Now our aim is how to calculate so that is the frequency deviation delta F indicated by frequency deviation is given by delta F. Another one is the modulation index. So that is given by modulation MF value. So in case of the amplitude modulation, it will be MA. So because here we are taking the frequency modulation techniques problem, so we are taking the modulation index MF. Another one is bandwidth requirement. That is the requirement for the AFM. First we will calculate what is the frequency deviation. So delta F is equal to KF into AM. So you know that from the given problem, we have measured what is the KF, what is the AM value. So AM, what is the AM? It is the amplitude of the modulating signal. So from the problem itself, it is the 5 volts amplitude of the modulating signal. Then KF is the frequency sensitivity. So it is given in hertz per volt. It is also getting from the statement, that is 40 hertz per volt. So you know that two parameters requirement for the calculation of the frequency deviation, that is delta f, is equal to AM into KF. So from this you have to calculate the delta f equal to 40 into 5. So delta 40 is the frequency sensitivity and 5 volts is the amplitude of the modulated signal. Overall frequency deviation is measured. Calculation will get cancelled. Remaining unit is only hertz only, 200 hertz. Why? Because so the frequency sensitivity KF is given by hertz per volt. It is a hertz per volt. The amplitude AM is given by, it is a 5 volts only. So we are getting the multiplication with the hertz per volt, volt gets cancelled. Remaining we are getting the only frequency. So that is the delta f is a frequency deviation, is always measured in the frequency only. So that we are getting the 200 hertz for this case. Then coming to the modulation index. So here the modulation index MFR, it is also indicated by the beta. It is also indicated by beta in case of the frequency modulation, and in case of the AM modulation it is given by MA. It is also indicated by MA. MA stands for, it is a modulation index of the amplitude modulation. M is a modulation index. A is an indication, it is amplitude modulation. So whereas in case of the FM is also indicating the MF, it is equal to beta here, what you have discussed. So it is also known as a MF. MF stands for, it is a modulation index for the F is a frequency modulation FM. So that we are getting the beta equal to delta F by FM. So you know that what is the delta F? So what you have calculated in the previous one, that is the frequency sensitivity is given by AM into KF. So 200 hertz. So we are going to use the, for this calculation of the modulation index for the FM, beta equal to delta F by FM. So delta F is a 200 hertz. Then what is the FM? So FM is a frequency of the modulating signal. So it is also getting from the statement. So we are getting the FM value from the problem given. So you can also calculate the, so beta, that is the modulation index of the FM, is equal to, we are getting the frequency deviation delta F by this mod frequency of the modulating signal, 200 by 2 into 2 kilohertz this is. So we are getting the 0.1 is the modulation index by calculating the 200 by 2 into 1000, 2 kilohertz, that is frequency. So overall the beta is always equal to 0.1. So that means what is the meaning of that one is, if beta value modulation index of the FM is less than 0.1, which is less than 1, hence it is a narrowband modulation index. So you can define the FM into two categories based on the modulation index. One is the, if the beta value less than unity, you can say that it is a narrowband frequency modulation. It is similar to our AM only. The bandwidth requirement is also equal to AM, that is 2FM only. So if the beta, that is modulation index, beta is greater than 1, then it is known as a wideband FM, wideband frequency modulation. So that is the based on the beta value. If beta is less than unity, it is narrowband FM. If beta is greater than unity, you can say that it is a wideband FM. So here the beta value less than unity, we are getting the, according to the problem or calculations, beta equal to 0.1 only. So that we can define that it is a narrowband frequency modulation. So the bandwidth requirement for this narrowband FM is equal to the AM only. So that for calculation of the bandwidth requirement for FM, because the modulation index beta value is less than unity, so it is equal to bandwidth of AM. So bandwidth requirement for AM is a 2FM. So 2 times to the modulation index frequency. So that here we are getting the bandwidth equal to 2FM. You know that FM value 2 kHz. So overall little bandwidth requirement is equal to 4 kHz only. 2 times to the bandwidth requirement. So that is this is about the given problem. We calculated all the things. What is the bandwidth requirement? What is the frequency deviation? What is the modulation index beta value? Then coming to the second problem. Here we can take the FM wave is given by the standard modulated wave S of t equal to 20 into cos 8 pi into 10 power 6 into 9 into sin 2 pi 10 cube into t. So calculate the frequency deviation, bandwidth and the power of the FM. So from this standard, compare this given standard FM modulated wave. S of t is a standard modulated wave S of t. So this the given problem can be compared with the standard FM wave. It equal to S of t equal to AC into cos 2 pi ft plus beta into sin 2 pi FMT. AC cos 2 pi ft is the carrier signal, and AC into cos 2 pi FMT into beta will give the bandwidth, the sidebands frequencies. So by comparing this one, you can easily calculate what is the AC value. By comparing this standard equation with the given problem statement, so AC equal to 20. So AC equal to 20 volts. The coming to the, so 2 pi means 4 pi. You will get the 4 into 10 power 6 is the our FC value. So modulating signal frequency, beta value is equal to 9. It is the wideband frequency. Because beta value is greater than 1, it is a wideband frequency modulation. Then coming to compare the FM, it will be equal to 10 cube. So 1 kilohertz, the FM value. So from this you have to take by comparing the standard equation with the given statement, you have to calculate all the things. Now from this AC equal to 20 volts, FC equal to this one, and FM equal to this frequency 1K, 4K, 4 megahertz, and AC equal to 20 volts. And modulation is beta equal to 9. So from this you have to calculate the frequency deviation. Beta equal to delta by FM. You know that what is beta value, and FM value, that. From this you have to calculate the delta F. You get the delta F equal to beta FM. So overall delta F equal to 9 kilohertz. So once you have the beta value and frequency deviation, so bandwidth, because the modulation index beta is greater than 9, it is a wideband frequency modulation. So bandwidth equal to, according to the Carson rule, it will be equal to 2 into beta plus 1 into FM. So you know that what is the value of beta, what is the FM value. By substituting this value, you can calculate what is the bandwidth requirement for the FM is equal to 20 kilohertz. So this is about the another statement, another problem for the FM modulation. So here you have to observe that what is the previous problem. So we are going to have the previous problem. According that, we have calculated the beta value is 0.1 only. Am I correct? So that is what is the based on the beta value. We are going to define what is the type of the modulation of the FM. So according to the definition of the beta value or value of the beta, that is modulation index. If beta value is greater than 1, you can say that it is a narrow wideband FM modulation. If beta is less than unity or 1, you can say that it is a narrow band FM. So for the first problem, you can see that beta value here, we are getting the 0.1 only. So that indicates the modulation type of the FM is narrow band, because beta value is less than unity. So coming to our problem here, according that we are going to calculate the bandwidth requirement, which is equal to the bandwidth requirement of the AM. So that we are going to FM only. So overall it is 4 kilohertz only. Then coming to the previous next problem, that is the problem 2. Here by comparing the standard equation of the FM with the given statement, we are going to calculate what is the magnitude of the carrier signal AC, what is the frequency of the carrier signal, what is the frequency of the modulating signal. So by this you can say that, and based on that we are going to calculate the correspond directly comparing this standard equation. We are also finding what is the beta value. So this is the 9 is. So you're getting comparing the standard equation with the given statement. So AC equal to 20 volts. This is the AC and 20 volts. And frequency of the carrier signal, this one. and frequency of the modulating signal FM will be give this one. So comparing this beta is equal to 9 here. So for the first case, first problem, we are getting the beta value 0.1 only, so that it is less than unity. So it is narrowband FM modulation. By comparing the second problem, so beta value directly given here, beta equal to 9. So that indicates the modulation taken here is wideband FM only. So by the support of this amplitude carrier signal voltage, frequency carrier signal, and modulating signal, so that we are taking the beta value 9, we can say that it is a wideband frequency modulation. Then according that, we are going to take the problem of the calculation of the beta value. So beta equal to 9. You have to calculate the frequency deviation. You know that what is the FM value. So by substituting the delta F and beta value, FM value, you can calculate what is the frequency deviation. So delta F equal to beta into FM value. So that we'll get the delta. This is the delta F only. So 9 into 1K will get the 9 kHz. So comparing the previous statement, that is the narrowband FM, there we are going to get the bandwidth requirement is only 4 kHz. Whereas in this case, we are getting the 20 kHz by calculating so because the difference you can easily observe that. So if it is a narrowband, it is similar to our AM modulation techniques, 2 times to the modulating signal frequency. Whereas in wideband frequency modulation, so there is a multiples of frequency sidebands is there, so that the wideband, the bandwidth requirement for the wideband FM will be more. So that we are getting the 20 kHz here. Previous and only 4 kHz, we are getting here 20 kHz. So by this, the bandwidth requirement, you can also say that it is a wideband frequency modulation. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.